okay, it's reading, and this seems to not be doing too bad, actually. Okay, so I tried this like a lot of times, and it really thinks I'm an AI. And by the 50th, it says, Bribriafone. Which of these two belongs to the charming carnivore himself, Jeffrey Dahmer? I found this article by Anna Karen Graphology Center Limited that claims that you can tell who's a serial killer or psychopath by their handwriting because, among other things, they've got extremely strong pressure and tense strokes. No, not like that, you perv. This all seemed a little bit dubious to me, if I'm being honest, until I scrolled down and read that Mrs. Karen, if that is her real name, ended the article with handwriting equals brainwriting. And wow, now I'm convinced. There's got to be something I can do to help this cause. And suddenly, it came to me. What if I could make an AI that can do this magical serial killer handwriting? And then I could make a game that could train anyone, including you, dear viewer, to be able to defeat these evil, sadistic, schizoid murderers. So let's put on our lab coat and get to work. I'm Fred, but better. This duct tape is definitely not covering up the name of my former employer that I stole this lab coat from. Anyway, okay, so you can watch this video without watching my previous one, where we kind of went over the basics of neural networks and built up to how to make a convolutional neural network, which at the end could read individual letters. This one kind of builds off of that one a little bit, and I'll be making some references to stuff from that last video. So you might want to watch it and come back to it, or you might want to click onto it at the end. There'll be a little end card that'll take it to you, and it'll fill in the gaps. So that neural network that we left off with did a fairly good job of reading individual letters, but they just kind of stuck a bunch of separate individual boxes next to each other and called it a word-reading AI. In reality, that's kind of a bit of a cheap hack, right? If only there was a way that we could make an AI that could read entire sentences, even when there are like spaces in between, and even when the letters are kind of combined in like a cursive-y or like a script sort of way. And obviously this is impossible, but maybe instead of just being able to read, it could write its own sentences? Maybe you could have another whole separate section that could tell whether a sentence that you fed into it was AI, or whether it was real? I mean, obviously that's way too good to be true, right? There's no way that could possibly... The engineers at Amazon did that? But the Mad Lads? Yeah, that's right. I was doing research into GANs for handwriting. Don't worry, I'll explain what a GAN is in a little bit. And out pops this like pretty much miraculous research paper called ScrabbleGAN, which does everything I could have possibly wanted to and a little bit of more. So I implemented it on my own and put it into Godot. But first, what actually is it? Well, the big drawback of the training process that we went through in the last video is that we needed like tens of thousands of handwritten letters, all of which had to be manually labeled with what letter they were. What if we had another AI that instead of reading sentences, it wrote sentences? Then we could train that AI based off of its own output. It would be like if you made a robot that could tell you exactly what ingredients go into a perfume, and then it would perfectly recreate that perfume that you fed it. Except at first it would be really bad at making perfume, so it would be like hooking up our sniffing robot to huff its own farts and expect it to make Chanel No. 5 by getting really good at discriminating between its own personal fart ingredients. So we still need some of these like pre-made inputs, basically get the ball rolling. But eventually, it gets good enough that its farts start smelling more and more like whatever this Johnny Depp ad is supposed to smell like, and then we can hook it up to start feeding its own outputs into its inputs. And better yet, we have to train two models, right? We have to train a reading model and a writing model. But what if we could train the two models, the reading model and the writing model, so that they were kind of working against each other? So what if the reading model gets points based on whether it can tell if the image that you're sending it was made by our fake generator, or if it's one of our, actual real sentences that we pre-labeled from our dataset? And what if you trained the writing model and gave it points based on whether or not it could trick our reading model and convince it that it's actually a real human? Well, that would be perfect, because if you can do that, you can basically just pit them against each other and have them fight to see who can improve faster, and you can sit back and relax while they fight it out for our approval. That's what I meant earlier when I said GAN. This stands for Generative Adversarial Network. Generative meaning we're generating human-like output, and adversarial meaning we're pitting our models to fight against each other. So the final architecture looks like this. We've got the generator, or the G model, which makes the handwritten sentences. And then we've actually got two different models that are trained to read, and they've got completely different jobs. We've got one, the discriminator, also called the D model, which all it does is guesses whether or not the image is made by an AI or a human, like I was talking about earlier. But then we've got a second model the reading model, which is also called the R model, and it tries to read the sentence and actually tell what letters make it up. Otherwise, it'll just kind of write gibberish and it'll just make an output that looks like an alien that got really good at writing letters but doesn't actually speak English. So the reading section of the AI is actually basically identical to the convolutional neural networks that we made last time, but with an interesting twist. If instead of writing one individual letter, we want multiple letters, what we can do is we can put in a recursive layer in the middle. What's a recursive layer, you might be asking? Well, now it takes a square letter-shaped box and it reads it, but before it moves on, it takes another box and puts it right next to the first one and multiplies it by the same weights. And before finishing off and adding the bias, it adds all of these different weights together. It can keep this going until it runs out of the width of the image, basically. And this way, no matter how wide your input is, you can just keep going until you run out of width, which is great because now we can have any word length or even sentence length that we want. The team did another really interesting thing, which is it actually didn't put the boxes next to each other side by side, it gave them a little bit of overlap. Okay, so this not only lets the letters bleed into each other, and they talk about how this is what gives it the intertwined styles like cursive and kind of script-like writing, but in my personal speculation, it also makes it a little bit better not forcing your letters to fit exactly into the box shape, which was completely required last time. So this is really cool. But unfortunately, the recurrent structure that we add in the middle has a few theoretical drawbacks. These issues are actually solved with more complex architectures. One you may have heard of is called the transformer, which is used in a lot of really cool stuff like LLMs and ChatGPT and that kind of thing. And wouldn't you know it, it's almost like I have a video planned for the near future that might have something to do with transformers. Wink, wink. Winking with the wrong eye, wink, wink, wink. And if you want to be notified when that video comes out, hey, what can you do? You can subscribe. Hey, look at that little plug right there. But for today, we're just gonna have to figure out a way to train around some of these issues with recursive layers. Okay, so that's how it reads, but how does it write? Well, actually, this is really cool. Basically, they just do the same thing as a convolutional layer, right? So the same thing that the reading model is doing and the same thing we were doing in the last video, but they do it in reverse. What? You might be asking? And yeah, I don't blame you. It sounded a little too good to be true the first time I heard it too. But this is how it works. So basically, you take a number and you feed it into this thing that looks like a reverse convolutional layer, and it spits out a grid of images that's bigger than your initial layer, right? So the convolutional layer shrinks down a grid into one number. This is doing the opposite. And you can keep feeding it this way with these convolutional layers to make it bigger and bigger until eventually you have an output that's the size of an image that you would want to generate. And you take all the numbers and you convert them to pixel values, and voila, we have an image. So the trick with writing is that you have a little toolbox of all of these different convolutional layers. One of these little sets of layers exists for every single letter. So for example, if the first letter in your input is an A, then you go and search around in your toolbox for the A filter. But if you only have one A filter, doesn't mean that every time you have an A, you get the exact same looking A? Mr. Strawman, but if you wouldn't have completely cut me off in the middle of my thought process. What I was about to say was that the key is what you put into the filter. Even though the A filter is just really good at drawing A's, it draws different A's depending on what number you feed into it. And with that little overlap on the edges, it also takes into account what letters are on either side of it, which also changes what the A looks like. Okay, but so what's happening here is that the input becomes extremely crucial because it decides what kind of A you get very reliably. And every time you feed in that input, it's going to look roughly the same for all A's, just with a little bit of difference depending on what letters on either side. But not just for the A, because you're training it on the same input every time, that means that it's going to reliably change the output of all of your filters. Do you understand what this means, Mr. Strawman? Do you get it? No, not really. Come on, Mr. Strawman, think! What this means is that based on the number you put in, you're deciding on the style of handwriting for the whole sentence. Oh, wow. Wait, actually that's kind of cool. Nice. So yeah, what this means is if you want to change the style of handwriting, if you want to change how the entire sentence is going to look, all you have to do is change that input. For example, if you find an input that looks just like Jeffrey Dahmer's handwriting, then you can save it, and every time you want to reliably get Jeffrey Dahmer's handwriting, you can just send it in as the input and get Jeffrey Dahmer style sentences. Okay, so let's take some of these features for a test ride. So I hooked up the model to work in Godot, and if you type in a sentence here and press enter, it makes a handwritten version of the sentence. Oh, it's actually working pretty well. Yeah, so we can get it to say some crude stuff. Yep, okay, very funny. Okay, yeah, okay, you child. Right, enough of that. And this is neat, but let's be honest, it's just an appetizer for the serial killer real deal that we're waiting for at the end of the video. We'll get back to that shortly. Before we get there though, even though this thing was made to create handwriting, it's got these two nifty little reading models sitting right here for us to play with too. So with the R model, we can read fully handwritten sentences, and with the D model, we can put an image and see how AI or how human our model thinks it is. Sounds great, right? The only issue is that, like I mentioned, that's not what this model was made for. It was made to write. And you can tell this by the fact that the only hint that I could find anywhere for how to actually use the models was in this GitHub issue reply, where somebody from the team said, oh, just root around in the guts of our robot and fish out something that looks like it might work. So I sliced open those robot intestines and found a way to get them to work. Fast forward past all of that, and here's a little game in Godot where, kind of like the big brother of the thing that we made last time, you can write in this little box and our AI will read it. And wow, it's not very good, huh? That's weird. Okay, well some of this is clearly my issue, right? One of the big issues from the method of writing into the box that I had from last time is that you have to move the mouse really, really slowly or else it skips a lot of pixels between frames. So I wanted to interpolate the mouse position between frames so you can kind of fill in a line. The most common algorithm for this is called the Bresenham algorithm, which is basically like a super computationally efficient way of finding all the pixels on a line between two pixel positions. It's time to try out the reading model with our new and improved system. Okay, it's reading, and this seems to not be doing too bad actually. Especially with relatively short sections. It does a pretty great job actually. Okay, and so what about the D model? Well, here's a fun little game I like to call Are You Actually an AI? Also known by industry professionals as the Real Actual Turing Test. You write in this box, and the model will tell you how likely it thinks that you're an AI based on your writing. Wait, hold on, let me try that again. Okay, so I tried this like a lot of times, and it really thinks I'm an AI. Does this thing know something about me that I don't know? What are you trying to say? So I even tried to fix this by simulating the writing being on a piece of actual paper by adding in some simplex noise to the empty background, and it made it worse? But let's do a sanity check, let's do a little control test. What if I take this random photo that somebody posted of their kid's funny homework answer on Reddit and fed it to the AI? Okay, so this is working great. So of course this should do the exact same thing if I take a photo of my actual handwriting on a real piece of paper and send it into the AI and... What the hell? Yeah, I genuinely don't know what's going on here. I tried with a bunch of photos that people posted of their handwriting online, and it does just fine with their photos, and yet everything that I try with my handwriting, it thinks that I'm an AI. I guess I just really write like a robot. Okay, one last small little fun thing that we can play with is that you can have it take a text, read it, and then write the same text based on what it read. You can make it repeat this as many times as I want, and through like natural errors that it's going to make, it's basically like you're forcing it to play a telephone with itself. So I fed in the word Libraphone. Why Libraphone? I don't know, it just kind of sounds like a funny word to me. You can see this starts off doing a great job, but by the 10th iteration it turns it into Abraphone. And by the 50th it says Bribriafone. And by the 90th iteration it's Andribitone. I did the same thing with a long sentence to see how it did with like spaces and stuff. It starts off doing a great job with the sentence, I am Word Homie playing telephone. By the way, did I mention that my friend named this thing Word Homie based on a little joke text that I sent him? Pretty fitting name. Anyway, so like I said, it starts off great as usual, but it goes off the rails like almost immediately. It loses all the spaces and turns into effectively gibberish, except funnily enough, it does a great job at keeping stuff like Tails phone and stuff like that at the end of the whole time, which is kind of surprising to me. Okay, but anyway, so those are fun little diversions, but now, how about we get to the main event, shall we? What this bad boy is really meant to do is grip the old ink quill and give us the au naturel serial killer handwriting, so let's put it to work. But before that, a quick scenery and outfit change. Step right up one and all and play a round of Guess That Murderer! That's right, can you beat the AI in figuring out which one of these inputs is a real psychopath serial killer, or are you destined to be fooled and probably murdered by one of these high level of intelligence schizoids? Find out now by playing along! First, a quick practice round to show you how it works. On top here, we have a snippet from the actual Zodiac Killer's letter, and on the bottom we have the same words but written by our AI. In the next round, I'm not going to tell you which one is which, by the way. I'll give you a few seconds to decide for yourself, and then I'll reveal it to you, as well as telling you the level of sureness that it had about the two guesses. And if you cheat, like, why? Why? You know, this is just like a dumb YouTube video for fun, right? Just like have some fun for once, man. Come on. So let's get right into our first round. One of these sentences is by the child murdering clown himself, John Wayne Gacy. Which one is which? I wonder if it's this one or if it's this one. Time's up! It's the one on the bottom. Did you get it right? Because the AI did. Next round. Which one of these two belongs to the maniac magnate murderer Charles Manson? Can you guess? Oh, I wonder. Is it this one? Is it this one? Which one is it? Time's up! It was the one on the top. Once again, the AI got it right. Did you? And finally, the guy on the thumbnail, star of a sort of kind of recent Netflix series. Which of these two belongs to the charming carnivore himself, Jeffrey Dahmer? Ooh, I wonder which one it could be. Ooh, is it this one? Is it this one? Time's up! It was the bottom again. And the AI clinches it. That's all for our game show. How did you do? More importantly, did you beat the AI? I mean, probably not, seeing as how the AI got all of them correct. Did you tie the AI, maybe? However you did, join us next time so you can try again on Guess That Murder! Man, I kind of feel bad about the whole, like joking about serial killer game show thing. I mean, I know like the joke is like you made a fun game show about serial killers, but I feel like I was having a little bit too much fun there. In any case, that's all for this video. I hope you guys enjoyed, maybe learned something new. Leave a comment down below with how well you did on our little game show, and if you have any feedback, criticisms, or ideas for future videos I could do. So this is the little sappy, honest part at the end of the video where I'm going to say that I was like genuinely shocked with how many nice comments I got on the first video. You guys were just like super kind, and obviously I'm a very tiny channel, so all of the kind words really meant a lot, and it really inspired me to work really hard on this one, and whatever, sappy stuff. Anyway, thanks again, genuine thank you to everybody who interacted with the first one, and whether you're new, whether you saw that one, whatever, thank you for coming to the end of this video, watching all the way through. If you liked the video, it would really help out if you liked the video down below, left a comment, subscribed, all that stuff. It really does seem to do a lot for the algorithm to actually show me to people. But yeah, regardless, thanks for watching, thanks again, and see you next time. Bye-bye!